Hi guys, welcome to my channel. Today I'm going to show you how to profile ransomware malwares, and I've picked 5 different ransomware types or groups basically from any.run, and I tried to build a MITRE ATT&CK framework to find the common techniques that are used by different samples to create threat hunting queries or to understand what different malware samples do in common. So let's start. As you can see, I've opened 5 different samples that they have different tags: Phobos and Revel ransomware and Lockshit or Lockbit and Server ransomware, and lastly a Ryuk ransomware sample from any.run. And we are gonna look at the samples processes to identify some common things and then move on to the attack framework and understand what techniques are used, and then I will show you the map that I created by combining these 5 samples. So let's start. Our first example is named as coronavirus.exe, and we see tags as COVID-19 and Phobos. And after the execution, it creates a command.exe and which deletes the shadow copies on the computer. The encryption is done by the coronavirus.exe, but in this sample, we don't see any network indicators or network related data about the malware, so the specimen doesn't try to connect to a C2 server in this case. Looking at the attack matrix of the sample 1, we see for execution it used system services and it used the command shell or command.exe, and it added itself into the registry to run basically on startup. And if you click the technique details, it shows you create files in the startup directory. I guess it adds itself into the startup directory and auto run value in the registry, which is used in persistence. The next one is browser extensions, modifies files in the Chrome extension folder. I guess if you click it, it will show you where and what when it happened on the sandbox analysis. And on privilege escalation, it uses again registry run keys. And on defense evasion, it renames the system utilities. Process drops legitimate Windows executable. Process creates files with names similar to system file names. I don't know if there's any file that is similar to coronavirus.exe, but it's listed. And on the credential access, we see credentials in files. And on the discovery, so these 3 are common in every malware ransomware specimen: software discovery, query, registry. So malware queries, registry, it tries to list or tries to know what software is installed, and it also does a system information discovery. And at last, of course, since this is a ransomware specimen, we see data encrypted for impact. This is common for all the 5 samples. And there is another line here that says inhibit system recovery. It deletes shadow copies. So 4 of the samples have deleted the shadow copy on the system. Only the server malware specimen didn't do anything about the shadow copies in the particular sample that I analyzed. On a sample 2, we see Revel and Sodino Kibi tags in the malware family, and after the execution we see command.exe which deletes the shadow copies via vssadmin.exe, and it also runs another command, bcdedit set default recovery enabled no. It disables the recovery and after that it sets the bcedit to boot status policy ignore all failures, meaning if Windows has a problem when it's booting, hey, ignore all that and start whatever it is. And after running those commands, we see nothing really interesting, but there's only a VSS service running on the computer. And in this example, we see a lot of network connections, and a lot of the network connections are started by the ransomware specimen. So some malicious file, as you can see, it makes tons of requests to different domains, but despite sending 219 sending DNS requests to 200 plus domains, on the HTTP requests side we see an IP address, and it is trying to get something from that IP address. It's downloading something, right? As you can see, it's then trying to post data, but it's nowhere to be found. 404 not found. These files are not found. If I go down, so basically this IP address may be the C2 server in this case. And let's quickly look at the MITRE ATT&CK matrix. We see the system services, command and script interpreter, and additionally, compared to the first sample, we see malware has created a scheduled task to execute itself, which is also a persistence mechanism, and which is also used as a privilege escalation on the system. And on the defense evasion side, it is trying to evade sandboxes by having time-based evasion tactics, like running after 1 minute or running after a couple of minutes or seconds to delay credentials access. This is also the same thing, unsecured credentials. It's trying to find credentials and files. And on the discovery side, it queries the registry, system information discovery, software discovery. These three were common also in the first sample. What is different is system location discovery, and also virtualization sandbox evasion is used. And on impact side, data encrypted for impact and inhibit system recovery. On sample 3, after the execution, after unzipping the file with WinRAR, the user executed the file. The file name is looking very awkward or unusual, like gpedit.msc.exe, which is looking like the gpedit.msc file or software on the Windows. And after it runs, it also tries to delete the shadow copies on the system via this command line, command.exe, VSS admin delete shadows, all quiet, and then it also deletes the VMI shadow copy service or something like that, VMI controller shadow copy delete. After that, we see the same command line as the second sample, BC did it, set default boot status policy, ignore all failures, and recovery enabled, no. And if I go down, there's an extra command that is unusual compared to the previous two samples, which is wb-admin delete catalog quiet. This is a command line used to delete backup catalogs on Windows servers. I don't know why is it doing that, but since this machine is not a Windows server, it's not going to do much. And after that, it opens the notepad and shows us logsheet, blacked, the world's worst ransomware since 2019. Your data is stolen and encrypted. And if we look at the attack matrix, we see system services, command, user execution. And on the persistence, it also registers itself, creates files in the startup directory. So it basically adds the gp edit msc.exe into the startup and into the autorun registry hive path as well. Let's see, let me just focus on the different things like credentials from password stores. So in the last sample, it was using credentials and files. This one, it is looking for like Google Chrome's database to find some passwords. And discovery side, software discovery, code registry, system information discovery, these three are the same, and impact is the same as well. The sample 4 is a malware ransomware family called Cerber, or a group called Cerber. And after the execution, it uses mshta.exe to run the HTA file, and which opens the read this blah blah.txt file with notepad. And after that, we see command.exe task kill, and it tries to ping the local host and exits basically. So the Cerber ransomware in this particular sample, it doesn't touch the VSS admin or volume shadow copies, but it makes a ton of network connections. As you can see, 2,201 connections. Maybe it's used to thwart and maybe misguide the analysts, because it's sending IP addresses or IP blocks that for a special port like 6893. As you can see, there is only data going out and nothing coming back. These are just whole IP blocks. And if we take a look at the HTTP requests, the mshta.exe actually tries to make a connection to API block cipher.com and then btcblocker.io, bitapps.com, also chain.so.com. But after that, we don't see any suspicious looking domain, and we don't see any connection that's made with the server5.exe here on the HTTP requests. And let's look at the attack matrix of the sample 4. System services, user execution, it uses command.exe, which is common. And here, defense evasion, it removes indicators, it deletes files on the system, and it tries to evade sandboxes. And on the credentials access, it's looking for credentials and files. Discovery, it queries the registry, system information discovery, virtualization, of course, and software discovery, what software are installed on the system. And on the CNC side, we saw application layer protocol. And on the last one, impact, of course, data encrypted for impact, and it stops a service on by using task kill.exe. So moving on to the last sample, which is a Ryuk ransomware sample. So this sample does a lot of things, and after running the specimen, we see a random process name like conwxp.exe, which does grant everyone to do everything on a file system, because it lets everyone to do anything under C and star, meaning it's just a wildcard, meaning you can do whatever you want to do under every file on the C drive. And after that, we see command.exe, VMI controller, shadow copy, delete. I guess there is a E missing here, but after that we saw vssadmin.exe delete shadows, all quiet. I guess this is the one that's gonna work. And after that we see, of course, bcedit, recovery enabled, no. And then it does stop some services, something, net.exe stop SAMs. I don't know what is it about right now, but let me go down. And here we see on the command.exe registry add hk current user blah blah current version run, meaning this con wxp.exe is added to the autoruns. So command.exe calls out registry.exe, reg.exe to add the key to the autoruns under the current version run. After that, I guess there is a winword process, desktop create report.rtf. After running the winword, we see run dll32.exe, which runs a DLL in the RTF file, rich text file, and the rest is msh.exe, readme.html. And I guess this is the end screen, pakurom 1977 at protonmail.com. And I guess this is it. And let me go to the attack matrix as well and see for the different methods and techniques used in this one. User execution, system services. In this one, we see VMI is used, Windows Management Instrumentation, VMI controller.exe. And let's see, cmd.exe is very common. Malware then added itself to the registry keys, run keys, defense evasion. So this one is different because it uses ICAC lsxe to modify access control lists. Let's see, registry, software, query, system information, the same thing. Data encrypted for impact, of course. It stops a service. I guess the task kill is equivalent to service stop. And then inhibits system recovery, which is related with the bcdedit.exe and deletion of the shadow copies. So this was the rundown of all the samples. I will now move on to the MITRE matrix that I created with these samples. So this is the MITRE attack matrix that I created, and I color coded the tactics and techniques. And let me give you the legend. And if it's 5 times, so if every specimen have the same technique or tactic, it is color coded as green. So every specimen was using system services and service execution. That's why they're green. If it's seen 4 times, it's blue. If it's 3, I color coded as red. And if it's 2, yellow. And if it's 1, like file deletion, it's orange. So every specimen was using CMD or command and scripting interpreter in some way. And every specimen was using Windows command shell, cmd.exe. None of the ones was using PowerShell or Python or different shells to interact. Every specimen, so 2 of the specimens was adding scheduled tasks to run themselves. And all of the specimens was using service execution. Let's go down to the persistence. 3 of the specimens, they added themselves into registry run keys. 2 of the specimens uses browser extensions. And of course, again, 2 of the specimens uses scheduled tasks that are coming from the execution itself as well. And on the privilege escalation, 2 of the specimens uses registry run keys. So defense evasion part is a little bit tricky. 1 of the specimen uses Windows file and directory permissions modification. 1 sample uses file deletion in the indicator removal. 2 samples or a sample that uses 2 methods uses match legitimate name or location, rename system utilities, and 1 sample modifies the registry. And let's go to credentials access. 4 of the samples used unsecured credentials, and 1 of the samples used credentials from password stores. On the discovery, all of the samples used query registry, software discovery, system information discovery. 1 sample used system location discovery, which is unique, and 2 samples used again virtualization and sandbox evasion. Only 1 sample I guess interacted with the C2. That's why anyone added this technique. And on the impact side, of course, every specimen encrypts the files. That's why data encrypted for impact is green. And 4 of the samples, they have a command line like bcedit recovery enabled no. So that's why it inhibits system recovery. And 2 of the samples stop services on the computer. I have created a matrix to find common tactics and techniques that are used by different ransomware families and groups, and how can I enrich and get something from that work or study. In my mind, I think I can create threat hunting queries to catch the most used methods like Windows command shell, meaning all the ransomware operators or groups, they use Windows command shell in somehow. So this is just a study of 5 specimen. Think of doing this in a larger scale. Let's say you analyze 300 ransomware samples and create a matrix map, and it will show you the most used ones. So you can write threat hunting queries against those MITRE attack techniques and techniques, which will improve your organization security, enhance your organization security, right? So one thing that I have in mind is the inhibit system recovery, which is like the bcedit. So by command line wise, I would create such rules, or I would hunt such command lines that have anything related with vss admin.exe, or any command line that has bcedit.exe. So these 2 are very common, right? That's why I focused on these 2. But there are also some very unique ones like file deletion or file modification. So any command line that has ICAC LCS, or I don't know how to read it, but ICAC LCS.exe, which interacts with the file permissions, changes the file permissions on the system. So I would wanna create some schedule searches to always alert on when this command line is used, because in most cases, if you see those command lines, it's either a system guy doing some work, or it's related with a real ransomware group or malware. So thank you for listening to me, watching my video, and I hope you guys see you in the next one. Bye.